So today on our table is this ancient tank of a MacBook. So the problem with this one here is that it has no audio or sound. So you're gonna join me as we go through the thought process of troubleshooting this relic, this tank of a MacBook. Troubleshooting and seeing what is causing this no sound or no audio. So join me, let's delve into this tank. I call it a tank because it's so bulky now. To the standards of today, this is a tank. So now we are on the audio coded page of the schematic. So this is the chip that produces or generates the sound for our computer. So over here, this is the chip in question. So we are going to check for the power supplies to this chip. Okay, so this chip has many different power supplies, about 4 different power supplies, in order for it to function properly. So we're going to check the 4 different power supplies to this chip to make sure that it's getting the proper voltage supplies it needs to operate. So let's get to our schematic here and then look for VD. The first one here is VD, and VD is a 1.8, that's PP1V8 underscore SO. So this is a 1.8 volts, and we can measure that on the pin 9 of this chip. So let's check for the pin 9 of this chip. Where's our board view? Board view. It's our board view, sorry. So this pin 9 is my board view oriented properly. Okay, so my board is oriented properly. So let's look for 1.8 on pin 9 of this chip. Okay, 1.8 on pin 9 of this chip. So let's check here. 8, 9. Okay, let's check around. It's over here. Okay, sorry. My laptop is not on. Sorry. So it's on now. So let's check for 1.8 volts on that pin. Okay, so we have 1.7. That's okay. I have it on this test point here. On this inductor, this coil. So we have 1.8. Let's look for the second power rail. VA. So we trace VA. That is PP4V5 underscore audio underscore analog. So this is the power supplies that goes to the analog side of this chip. Alright. So the analog side of this chip. So we are supposed to read 4.5 volts on this rail. So we can check that on any of these capacitors, C6218, C6217, so on. So let's look for one and use it to check for PP4V, that's 4.5 volts. Okay, where's my board view? Sorry. Alright, so C62, so we can measure 4.5 volts on this capacitor. So let's check for that. This is that capacitor here, here, and we have 0.301. Yeah, so we are not getting 4.5 volts. Alright, so we are not getting the analog V in, that's 4.5 volts to this chip. Okay, let's look for VHP, that's PP5V underscore S3. So these are all different voltage rails that power this very chip, right? So when you turn on the machine, where it chimes, there is a power, there is a voltage that is supplied to the chip. Not all the voltages are supplied to the chip when the machine is and maybe it's about booting. So when it's completely booted, you get all the power supplies. When it is in sleep or off state, it has a voltage supply that fits it. So probably when you plug in your charger and maybe you don't have a RAM plugged in, you get a beeping sound. This chip is creating that sound. Alright, so all these voltages need to be present at a very particular time to determine what this chip does at a very particular time. Alright, so now let's check for the next power, which is PP5VS3. And we can check that on capacitor C6213. C6213. Let's check here. Okay, so we can check that here. So let's check here. That's here. So that is over here. So we are looking for 5 volts on this capacitor. And as you can see, we have 5 volts. So let's continue with our search. So the last voltage we need to check is PP3V3 underscore S0 or SO, and we can find that also on C6215. C6215. So this is C6215 here on the side, just right here on C6215. So let's check for 3 volts here, and we have 3 volts. So we have all voltage rails except the audio coded analog voltage. We are not getting, so we are not getting this voltage. So this would be our problem. Let's see where this voltage is coming from. It seems to be coming from, let's see, where is it generated? Alright, so this 4.5 volts power supply for coded Apple. So this is the power supply that's feeds the audio channel or the audio module of this IC. So this is the power supply that creates that voltage. So let's look for this power supply on our board view here. Let's look for that power supply. I've opened the wrong schematic, the wrong board view here. So let's look for that chip. Let me copy that. So this Max 8840. That's the chip that creates 4.5 volts for the audio codec. Alright, so here's that chip. So what we're going to do is going to measure the input size of this chip. Alright, we're going to measure the input size. We're going to measure the input size of this chip and compare it and measure the output side of it as well. So for view again, so pin 1 of this chip is the input side of it. So this input side there receives 5 volts. Alright, so it receives 5 volts. Let's look for this here. Let's look for this here. So that is that chip. That is that chip. So this is our pin 1. Pin 1. So let's check for let's check for let's check for 5 volts on this pin 1 of this chip. Alright, so this chip is receiving input. That let's check once again. 5 volts to the input of this chip. It has input. Okay, let's look at the next pin. Shut down. So this is the enable side of this chip, right? The pin that tells it to what? Turn on. Alright, enable. 4v5 underscore red underscore enable. So you receive an input voltage here. That's 3.3 volts to enable it or to turn it on, or to tell it to output 4.5 volts. So you need to have a high voltage there, that is 3.3. And when the voltage is low, once one is 0, it shuts it down. So this thing here tells that shut down when it is low. So let's look for pin 3 on this chip. Pin 3 on this chip and see if we get a voltage on it. Yeah, so that's the pin. So it gets an enabling thing now. Alright, so this chip is getting all the necessary supplies it needs. Now let's check for the output of it. Now let's check for the output of this chip. That's pin 1. Let's check for the output of this pin 1 over here. See if you get 4.5 volts on the output side there. As you can see, you have 0.13. So the output side of this chip, let's see the output side of it again, once again. As you can see, we're getting 0.19, which is too shy of the required voltage, that is 4.5 volts. So this chip is a culprit here. So we change this chip and then see if we get audio. It got so noisy out there that the prudent decision to make was to do a voiceover for this portion of this video. Alright, so on your screen is me replacing the 4.5 volt power supply for the analog audio side of this sound IC or audio IC. Alright, so I have to replace that IC and then do a couple of other tests, and we even ended up replacing a capacitor and the audio IC itself. Okay, so so we ended up replacing the 4.5 volts power regulator for the audio IC. So after the replacement, we're gonna take readings and compare it to before. Right, so we start from let's start from the initial, right, from the input of the audio power regulator IC, which is our pin 1. Alright, so take it from there. Pin 1, we have 5 volts. Alright, then we go to the other side. Pin 3, which is the enable. Pin 3 enable 3.3, right? So the enable voltage is what tells the chip to enable the output or to output the 4.5 volt regulator. Something like the switch button to turn on this regulator or to allow it to output is um, design regulated output voltage, which is on pin 6. So we check at pin 6 also and see what we have there. And we have 4.5, right? So now as compared to before, where we were reading nothing, now we are reading something here. As you can see on the meter, we have 4.48, which is 4.5. But um, there is a twist to it. There is a twist to this, okay? So after replacing this power regulator IC, still I wasn't getting my 4.5 volts. So then I had to check for a short on this line. And surprisingly, when I checked for a short, the capacitor, this capacitor was shorted to ground. This capacitor was shorted to ground. So um, I had to replace this capacitor also before I was able to get 4.5 volt on this output. All right. And I can't tell as to if that chip was shorting my output voltage though. But I mean, if that capacitor was what was shorting my output voltage though, that it could be, and it could also be that that capacitor had drained too much power out of that regulator and killed it. So I changed that capacitor, and I was now getting my 4.5 volts. So after getting my 4.5 volt, I still wasn't getting any audio. So I ended up placing the audio IC also. As you can see, flags around this. So I ended up replacing the audio IC. So it became kind of like a rabbit hole, okay? So it started with replacing this power regulator IC, replacing this capacitor, and then replacing the audio IC. Then eventually we started making progress. So now if I should check on the if I should check on the sorry on this audio IC U62 U6201 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 and look for all its power supply voltages, we will see that we have all the power supplies available. So let's do that. Let's check pin 9. Let's check pin 9 here. Pin 9 will be somewhere around here. See. Pin 9 is here, so counting from 1, 1, 2, 3, 4. Okay, so let's count from here. 1, 2, 3, 4. No? Okay, my body's off. Okay, so it's on now. So let's check pin 9 here. So we have 1.8. Okay. So the first power supply is available. Now let's check the other power supply. Which is pin 24. We need the 4.5 volts. Okay, that was missing earlier. 4.5 volt, that was missing earlier. Let's check it on. So pin 24. Check it on pin 24. We can check it across this capacitor. So let's see pin C6218. So C6218.
Okay, P9 across this inductor.
And check it on this capacitor up here. This capacitor up here. And now I have a 4.5. Okay, so now let's check the next power supply, which is PP3V3SO. PP3V3SO, which we can measure across any of these capacitors, C6216, C62. So we measure 3.3 volts. We measure 3.3 volts on pin 3. Check on the schematic. Our pin 3 comes here. And this is a 3.3 volts. So we measure it on pin 3 here on this side. So let's check pin 3 here. You can measure out on this capacitor C6216. Capacitor C6216. Let's check it over here. So you have 3.3 watts. So our next power line will be 5 volt PP5V underscore S3. And we can measure that on pin 46. You can measure it on across any of these capacitors, C6214, C6213. And that's pin 46. So let's check pin 46 here. Pin 46 is here. So you can measure it across this capacitor here. So that will be the one down here, the one down here. So let's check it here. So we have 5 watts. So now we have all our power supplies on the audio IC. So let's check. Let's put this machine together and check if we have audio. All right. Let's assemble it and see if we have audio.
Moment of truth. So that chime sound in itself is a huge proof enough that we now have audio on this 2010 MacBook Pro 15 inches. So it worked. We fixed this machine. This machine is now working. We did well. So let it boot up into the OS and then let's check it in the OS and check the volume icon over there. So let's just wait for it to boot up. So as you can see there, when I press the volume icon, slide it, it works. It wasn't like this before. So it means if you've restored audio back onto this computer, this MacBook. So we did well. And I hope you learned something over here. The thought process I used to diagnose these faults and restore audio onto this machine. So subscribe, like, share, because we have more of such contents coming your way on this channel. Thank you. Bye bye.